number 13. When I do this one, if we use u substitution, I would let u equal what's inside. But notice du would end up being 3x squared, and I don't have any x squareds, and you can't introduce a variable. So how can I simplify this in order to integrate it? I can FOIL it, yep. So that's what I would suggest doing first. If you FOIL, you get x to the 6th plus 2x cubed plus 1. And then we can integrate that fairly easily. And remember, with these problems, you don't have to show your work here. So if you know I can integrate this, I know this is going to be 1/7 x to the 7th, so that's one of these two options. And then what would I get here? 1/2 x to the 4th. So that automatically gives me this one, so I can circle it. Yeah. So you don't have to show your work on the multiple choice. Just get to a point where you could just look at the answers and then compare to get the right one. Okay. Number 14. Okay. For number 14, this is a slightly tricky one because it's going to be a little, but I actually think maybe one like this popped up in the practice exam from Saturday. Do you remember the limit definition? As x approaches 0 of f of x plus change in x minus f of x all over change in x? Remember when we had to do, derivatives the long way? Okay. That's not what you have to do here. You just have to recognize that this is set up like that.
Wait a second.
Except, hold on. In this case, instead of change in x, they're using h. That's pretty common that they use h instead of change in x, but they mean the same thing. And instead of x, they're using what? They're using 2, right? What they're trying to get you to see here is that this represents the function e to the x.
What?
Oh, yeah, I got it.
Okay? If my function was e to the x, and I told you to find the derivative using the limit process, using the limit process, we would have to plug in x plus change in x, right? Minus e to the x all over change in x. That's how we would normally set it up. This is the exact same setup here, except they're telling you that x is 2. They're plugging in 2 for x, and they've used h, and they've just used a different variable instead of change in x. But it's the limit definition of derivative. So they're trying to get you here to say this is finding the derivative.
Wait, how do you get from finding the limit, finding the derivative?
What?
How do you get from finding the limit, finding the derivative?
Because when we were using the limit definition like this, when we first started doing derivatives, this is how we found the derivative, by doing this. And then we use like rules after that to simplify the process. But this setup means find the derivative of, I think it's e squared, because they've plugged 2 in for x. So what's the derivative of e squared?
E squared. 2e squared, yeah.
No, 0. 2e squared, 0. Because e squared 0.
No, yeah, because you have to do the integral of 0. You're just right.
E is the number 2.718, right? And if you're squaring it, it just makes it a bigger number. What's the derivative of a big number?
0.
Nothing. 0.
What?
So it should be a.
Why should it be a?
Oh, okay.
Yeah, e is a number. Yeah.
I was like,
But it's a. So basically, that's just giving us the derivative, and we just need to take the function and plug it in. We don't need to take the derivative of the function.
What this is trying to get you to see. I feel like there's lots of conversations going on right
Wait,
now.
we don't plug in the 0 to the function. Like we don't.
Let me explain from the beginning. As long as everybody's listening and not talking on their own here. All right. I know this question showed up on the practice exam from Saturday. Since it's on the AP exam also, I would assume that they're probably going to have at least one like this on the AP exam. No, because sometimes the function is different. I think the one was a polynomial, the one from Saturday. But when you see something set up like this, where it might look like it's set up in the limit definition process, then they're just wanting you to look at the function and then not plug 0 into all of this because you can't. You can't simplify that at all. It's to recognize that this means find the derivative value of e squared in this case, because they tell you to plug in 2 for x. Right. So again, they're just trying to get you to make the connection that this is the limit process definition of derivative.
Oh, it's not. Okay. That explains it.
Right.
And then they're kind of tricking you because normally you want to treat e as a variable.
Right.
But you have to, it's a number.
Right. Okay, so A is the answer there. All right, go ahead and flip. 15, slope field for a certain differential equation is shown above. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 1? So if you look at where y of 0 equals 1, where's...
1 is up, up, up.
Oh, thank you. Right there?
Yep.
If that's a point on my graph, and this represents all the different families of functions that I could have, it kind of looks like there's an asymptote down here, right? Because it kind of all bottoms out, and then there's an asymptote right there.
Yeah.
So if you look at your functions, does cosine have an asymptote?
No.
No. Does the polynomial have an asymptote?
No.
No. Does e to the x have an asymptote?
No.
No. Does a square root?
Yes.
EDX does.
No, a square root does not have an asymptote. A square root starts and goes one direction,
Yeah.
but it does not have an asymptote that it follows.
So that.
So it's got to be a rational function, e.
I thought EDX does have. Doesn't it? But not both sides.
It doesn't have it has a horizontal asymptote. It does not have a vertical. Yeah. So rational functions have a vertical and a horizontal asymptote. That's the only rational function that I have. So that's my option here. Yes. TJ.
Irrational
Okay.
mean X is on the bottom.
Yeah, rational means that you have a function of x in the denominator. Okay. Flip to 16. Okay, if your derivative is the absolute value of x minus 2, which of the following could be the graph of f of x? First of all, you need to know something about this graph. This graph is in what shape?
A V.
An absolute value, which would be a V, right? And then that 2 moves my graph to the right 2. So they throw this one in there because that's actually the graph of the derivative. Okay, that's not the... I can eliminate that as an answer right now because I want the graph of the original, not the derivative, yeah?
Since we know that that's the graph of the derivative, can't one it just be c because derivative x-intercepts are maxims on the original?
Correct. Oh, hold on. I gotta look at all the graphs here.
Yeah.
Yep.
Well, no, it could be a minimum.
No.
It could be a minimum too.
But there is no graph on derivative.
Okay, remember with derivatives, if we know that this is my derivative graph, where the derivative is positive, my function should be doing what? Increasing.
Which, since it's all positive.
Since it's all positive, your entire original graph has to be increasing. The only time that happens
E and D.
is E and D. But with the derivative graph at 2,
Oh yeah, but it's a cusp, right? Isn't it?
well, it can't, if this is the derivative graph, the derivative would not exist if we had a cusp or a break in the original.
Oh yeah, so it has to be E.
So it has to be E. We have to look at this in the derivative graph as a minimum. So we have, wait.
But that's the point of inflection at 2. More minimum.
Can we just integrate this for absolute value of x minus 2?
No. Let me think about this.
It's not a max or min at either of them, though. Like at D,
Right.
it's not a max or min. E is not a max or min.
Hold on a second. Let me.
I think it might be a different thing.
not a pilot question.
What was the pilot question?
16. Okay, they're saying it's E. I think here, because it's a 0, we know the original graph has to have a tangent line that is 0. So it doesn't mean that necessarily you're going to have a max or a min, but you do have to have a tangent line that would be 0, and a plateau point does have a tangent line of 0. So we're okay there. It can't be a max or min anyway because your entire graph is a positive, so you're not going to change. Yeah, so it doesn't have to be either. All right, for 17, we're trying to find the area enclosed by the graphs of x minus 2x squared and negative 5x. What you have to realize here, you don't need to, hold on, you don't need to know, you don't need to graph both of these perfectly, but you do need to know the general shape. So we have, hold on, a quadratic that opens what direction?
Down.
Down. And you have a line that has what kind of slope?
Negative.
Negative. So you're going to have this scenario. So what function is going to be on top?
The parabola.
The parabola. That's really all you care about here. You don't need a perfect graph. You just need to know which one's on the top so that when we find top minus bottom to represent my area, I have the right function on top. All right, so when we set up the area function, we will be integrating. Well, I'll figure out my limits of integration here in a minute. But to get the length, because remember, for area, you're finding the area of one representative rectangle, so we need length times width. The width is my change in x. The length is going to be top minus bottom.
Change in x is the same as dx.
Yeah, sorry. I'll label that as dx. So top minus bottom here will be x minus 2x squared minus 5x, which will actually make it a plus 5x. And then times dx. Now I know I can simplify that a little bit before I actually integrate, but I need to find my limits of integration. If they're not given to you, how do you find them?
Set the two functions equal to each other and set equal to 0 after you get it all on one side.
Okay, so if I set them both equal to each other, I'm going to move this x over. So I get negative 6x divided by negative, well, actually, I'm not going to move it over that way, sorry. Move everything over to the left because I'm going to have to be able to factor this. So I get negative 2x squared plus 6x equals 0. Pull out a negative 2x, and I get x minus 3. And so my two boundaries here where they intersect are going to be 0 and 3. Then before I integrate, let's go ahead and simplify that to be 6x minus 2x squared. And then if I integrate, I should get 3x squared minus 2/3 x cubed. Is that right? Okay. And then we're going to evaluate that from 0 to 3. So really all I care about is when I plug in 3, what do I get? Because when I plug in 0, I get nothing. So when I plug in 3 here, 3 squared is 9. 9 times 3 is 27. When I plug 3 in here, 3 cubed is what? 27. And what's 2/3 of 27? 18. And so 27 minus 18 would be what? D. Okay. Any questions so far on that one? Okay, number 18. For the function f, they give you the derivative and an initial condition. What's the approximation for f of 1.2 found by using the line tangent to the graph of f at x equals 1? That is a mouthful there. All right, but if we, don't we have the, what's the approximation for f of 1.2 found by using the line tangent to the graph? Sorry. This is the point they're giving me. Okay. They want us to find the line tangent. So I have the derivative, and I have the value they want me to find it at. So I'm going to plug 1 in. So f prime of 1 gives me what?
4, they already gave that to you.
prime of 1. Because I'm trying to find the slope of my tangent line. What's f prime of 1?
3.
3? Okay, so this is going to be my slope of my tangent line. This is my point that the line goes through. Because remember, to write the equation of a tangent line, I need an x and a y. My x is 1, and they're telling me when I plug 1 into the original, I get 4. So my line tangent is going to be y minus 4 equals 3 times x minus 1. Now, the approximation using the line tangent is plugging 1.2 into this, instead of finding the original equation and plugging 1.2 into there, because you're just finding an approximation. Okay, so this is common. If they mention the line tangent to the graph, they want you to find the tangent line and then use the tangent line to plug 1.2 in. So it should be 4.6. So we plug 1.2 in there. So you get y minus 4 equals 3 times what? 0.2. And then you'd add what? 2 is 2/10 or 1/5.
I was thinking it was 3 times 2. I tossed it at the
Right.
decimal.
Okay. Yeah. And so this would be 3/5 plus 4.
Would you get the same answer if you put it in y equals mx plus b format?
Yes.
Yep. That's what I did.
That's what I figured.
Well, I simplified it and I didn't get the right answer.
It should be 4.6.
Yeah,
Yeah.
I
Check your.
simplified and did the same thing.
When you simplify, you should
Oh
get.
shoot, never mind. Fuck
Okay.
me.
So 4.6 at the end of it. This is a pretty common question too. Did everybody get why we had to do it that way and we couldn't just integrate and plug 1.2 in?
Yep.
Okay.
You had to use your y.
Because it mentions use the line tangent, so we had to find the tangent line and use that to plug 1.2 in. Because that would be easy to integrate and plug 1.2 in, but that's not the way they wanted you to do it. Okay, number 19. And we'll go to 20, I guess. For number 19, find, I think where the graph is concave up. So let f be that function. The graph is concave up when ... So we have to use what derivative here to find concavity? Second derivative. So first derivative would be 3x squared minus 12x. Second derivative would be 6x minus 12. I have to set that equal to 0 to find the critical value for my sign chart. So x would be 2. Then I evaluate something to the left and to the right. So maybe plug in 0. And we're plugging 0 into the second derivative. If I do that, I get negative. And so I'm assuming if I plug in 3, I get positive. So it's going to be concave up for x values greater than 2.
Where's it? Oh, that's A.
Yeah.
So clearly I need to brush up on my greater than sign. Because I always think, alright, 2 is here.
Mouth opens up to the big one.
What?
Alligator mouth opens up to the big one.
That's how I always remember it.
Yep.
Awesome sense of general horizon. So it's A, right?
It is A, yes.
I used to do T.
I used to draw entire bodies.
Oh dear. I think we're all losing it. Okay, 20.
Oh, JB.
Okay, for number 20, if g of x is that polynomial and f of x represents the derivative of that, then evaluate from 1 to 3 f of x.
Wouldn't it just be G of X?
Yeah.
Isn't that just a little bit? Yeah, it would just be G.
It'd just be G of X and you plug in actually.
Let me hold on. I just want to make sure that I'm not being tricky here. If this represents the derivative of that, which the derivative would be 2x minus 3, right?
F of x is G of x. F of x is the derivative of G of x.
Hold on. I'm just trying to make sure they're not being tricky. In order to solve that, we'd have to integrate, which would be this, and we'd plug in 1 to 3, right?
Yep.
Why would they give you that?
Well, you wouldn't get the 4, would you? Even back
Huh?
to the bottom of the thing?
-2.
When you integrate back,
You just weed
When
out
you
the 4.
integrate, you wouldn't get the 4.
yeah, it'd be plus 2.
Is it f of x plus or
Oh.
g of x and
Yeah.
f of x minus?
You just
this is saying, okay, they're giving you this function. They're saying that the f of x in here is the derivative of this. So that's the derivative. So really what we're looking at is this. Let's do it this way and the other way and see if they both end up working out. I don't think that they're going to be the same. When I integrate this, I get x squared minus 3x, and we're going to evaluate from 1 to 3. When I plug in 3, I get 9 minus 6, which is...
No, 9 minus 9.
Oh, duh. 9 minus 9, which is 0. And then you subtract what you get when you plug in 1, which would be negative 2. So you should get
If you do
positive 2.
If you do it the other way, you get 6. So negative 2's right.
So
Which
it
6
would
isn't
be-
even an option.
Yeah.
You just gotta drop
negative
off
2's
4.
right.
Yeah, you just gotta drop off the 4. Yeah, so that one was a little tricky.
Careful the
Don't
time
rush.
fast.
What would help solve my problem of accidentally switching signs and...
Okay, what I'm going to do now is I'm going to give you a free response problem that is similar to ones that we have done before. I'm going to have you work with the people at your table, and if one of the 3 gentlemen in the middle would work with TJ, so that he has somebody to work with too. I'm going to have you work on that for the last 10 minutes, and then we will go through it together as an intro tomorrow. So instead of me just walking you through it, I'm going to have you try it on your own, but it's similar to ones that we've done before together.